Okay, plane mirrors. These are mirrors that are flat. Okay, so when we talk about plane mirrors, we're talking about flat mirrors. These are smooth surfaces, and light can be reflected by specular reflection, remember, because it's smooth. And then you can see an image. This is what you guys look into every day when you put on your makeup or you get dressed or whatever. So we have this lady, and she's standing in front of the mirror. Like I said, I'm really bad at drawing things. This is supposed to look exactly the same. I know it doesn't look even close, but this is supposed to be the same lady. I don't know why her neck is so long. She's like a giraffe or something. And this is the original thing, the real life thing, like this lady in this picture. That's her. And that is known as the object. So the actual thing that's looking into the mirror is known as the object. The thing that you see in the mirror is known as the image. Okay, and we're going to talk about a couple properties of plane mirrors that actually make them really, really good for the things that we use them for. Any other type of mirror would not be so useful. If you guys have been to a fun house, you can imagine putting on your makeup or brushing your hair or something in one of those weird curved mirrors. It wouldn't work all that well. So here we go. We have a plane mirror. This guy's sitting in front of it, and there's like a bird up here, a cardinal, I guess. And plane mirrors make a virtual image. A virtual image is formed by diverging light rays. Diverging. Okay? Now, diverging means like spread apart, not coming together. When you guys leave school, you diverge and go to your separate houses. So, this is formed by diverging light rays. So, and we'll learn how to draw these ray diagrams, don't worry. But basically what's going on is from this object, you actually have a human here, right? He's not going to just be there by himself. Or the birds. This isn't a mirror that just shows like birds and not humans. So, but the image of this bird, the light is hitting the mirror and diverging off, right? We've got this angle of reflection. And then what happens is the light kind of passes, or it looks like the light is passing through, and it creates a virtual image. And this is not a real image. It's not on the real life side. It's a virtual image. Okay? And it's formed by diverging light rays. You can see these rays. They're not coming together. They're diverging. So some properties of these plane mirror images. The image appears the same distance behind the mirror. Okay, so this distance and this distance are the same. Can you imagine if you were trying to put on your makeup and you were trying to like do your mascara or something and you got really close and the image actually got farther away? That would be really hard to do your makeup. The image is the same orientation. That means it's right side up. Again, can you imagine if you were trying to brush your hair in the mirror and the mirror had you upside down, right? So your hair would be like going like this. That would be really annoying. And the image, again, is upright. Okay, so it's the same orientation. It's upright. It's not going to be upside down, and it's going to be the same height. Okay, so this height and this height are exactly the same. Can you imagine if when you were trying to, again, put on your makeup, and the closer you got, the smaller the image got? That would make it, again, really, really hard to do anything useful in a mirror. So all of these properties of the mirror are things that we kind of take for granted, but are really useful. Now, here we go. This is our quote-unquote equation for the plane mirror image position, because it's not really an equation. It has an equal sign, but it's pretty easy. And what they're saying is the image position is equal to the negative of the object position. And all that's saying is your object position is on this side, and they consider that positive. And so this, they have it backwards. Let's see, we'll call this the object, Well, we'll leave it. Okay, so this one's a little backwards. This is the image, and this is the object. And so this object position is considered, usually we consider it the positive side, and so the image is just the negative of that. And this equation is just putting it in the opposite way. You could also write the equation dO is equal to negative di. It would be the same thing. And so this is the same distance away from the mirror, just on the opposite side. And that negative lets us know that the object is virtual. So if you don't see a negative, like when we start talking about lenses and things like that, then you know that the image is a real image. Now, the height, again, with a plane mirror, this is really easy. The height is the same size. They're the same height. Now, when we start doing lenses and things, you could have your object height like this and your image height like that, and that would be, this would be HO and this would be negative HO, okay, or HI. So if you have a negative height, that would mean that your image is upside down.